Good day, DeWolf chemistry students. It's me, Mr. Cheney, with another brilliant tutorial. Today we're going to be talking about the water hydrogen gold lab that's done in the online textbook, Savas Bridge. And so here it is in Google Classroom. Started it as a class yesterday, and this tutorial is for people who may not have been here or who just need some extra support for what we did as a class yesterday. So there's slide decks, and we need to open up the lab from the textbook. So that's, we go through Clever to do that. So we're going to go to Clever, and we're going to log in. And for you guys, you're going to my class page, so you're going to find Cheney's page, and you're going to go to Savas Easy Bridge. And for you, when you open it up, you're going to click on the textbook title, and you'll see like your assignments pane. You'll click it from there. It's slow, so I'll show you what that looks like. So each of you has a pane that looks like this, just one because you're only in one class. Virtual Lab States of Matter is the one that we're doing. So we're going to click on that. And it's the scoring page. So I actually want to go back. Can I do it from here? How you do it, we'll do it from the student page. I'm going to do it here. Here we go. Alright, so now that we have the lab set up and we have the Google Classroom ready to go over here, I'm going to open up the slides. I'm just going to walk our way through what we need to do. Just give you an example on some of them. First slide, obviously, you're putting in your first and last name. Second slide, where do we find the information for this? Well, we read about this Pluto information, fascinating information. Bottom line, they have frozen nitrogen on there, so that's why this lab is applicable. We go to the Investigate tab, and we're going to go to each one of these substances. Liquid water, nitrogen gas, solid gold. And so we go to water, we press this play button. What it does is it shows us the three different ways of movement for a liquid, and specifically liquid water. So translation, rotation, and vibration. And over here in the paragraph, it does tell us the same information that liquid water does exhibit all three: translation, rotation, and vibration. Later on, for the second table on our slides, we're going to need this information, the boiling point and freezing point of water. But for right now, we just need this information. So we'll go back to the slide. And this is what they're asking. This is the first table. Motions the particles undergo. So the three: translation, rotation, vibration. For liquid water, it's all three. If we were to go to solid gold, you'll see that it's only one. So if I play this, since it's a solid, there is no translation, moving back and forth or up and down or across each other, and there's no rotation of the molecules. It's just vibration. So that's what we're going to put in the table. And I'll have you go do nitrogen gas on your own. So now, the second table. Boil temp, freeze temp, melt temp. And you've got Celsius and Fahrenheit. Now for solid gold, there is not going to be a boil and freeze temp. There's only going to be a melt temp. And for liquid water and nitrogen gas, they do not include a melt temp. So you can put Na for those. And for gold, these are going to be Na as well. But you will look up these other two. So for liquid water, which we were on previously, I'll click on that, it shows that water boils, and we've learned this before, that it's 100 degrees Celsius, 200 degrees Fahrenheit. So we'll put that in the table right here, 100 degrees Celsius / 212 Fahrenheit, and then we'll do the freeze temp as well, and we'll do that for nitrogen, and then we'll do the melt temp for gold. Okay, next slide. Go back to the lab, We're to the Analyze tab now, and once again we're going to go to each material and we're going to see what's what. So with water, we can see that water is liquid at 20 degrees Celsius. It's still water at 70 degrees Celsius, but we can see that it's moving a little faster, that translation, rotation, and vibration are happening. And at 120 that's above the boiling point, so that's when it starts getting into gas. Okay, so the steam that we've seen before. What we're wanting to find is solid water. So let's start with solids. Solid water, otherwise known as ice, negative 20 degrees is when it starts, and it stays ice all the way down, so the range that we would want is negative 20 degrees all the way to negative 220 degrees for solid water, otherwise known as ice. So we'll go back here, solid water, which is ice, and we're talking about particle arrangement. So when we're talking about solids, we're talking about tight together and they are vibrant. For solids, liquid's going to be different, gas is going to be different. So here's the range that we found for solid water, otherwise known as ice, negative 20 to 220. And so you're going to go down and you're going to do that for each material by returning to the lab and changing the substance, and you're going to find where the solid is. So for nitrogen, solid is way down at negative 220, and that's the only temperature that it's at, that it's a solid. And then you've got to find the range for gaseous nitrogen, which looks like there's quite a range. So you do that, it just gets faster the higher the temp is. And then you'll go back and you'll do the Goldwire as well. And once you've got all this table filled out, you're going to go back and you're going to get these screenshots. You can actually do the screenshots at the same time. So we've got 3 solid, 2 gaseous, 1 liquid. So water is the only liquid that you're going to record. And you've got water as a gas, you've got nitrogen as a gas, and then the 3 solids. Solid water being ice, nitrogen, solid nitrogen, and then solid water. And that's the lab. Hopefully this is a helpful tool. If not, well, it will be. But if not, I will be in class to help you live. See you back in class.